Question 20. The diagram below shows an interferometer with two paths, path A and path B, which a wave can take from its source S to a detector D. The lengths of the paths differ by an amount L, which can change with time. The intensity at the detector I is measured and varies as a function of L as follows. I equals IP plus IQ cos KL. In the above, K is the wave number of the wave, which relates to the wavelength via K equals 2 pi over lambda. IP and IQ are constants. Sketch the intensity as a function of L in the range from 0 to 2 lambda. Label both axes and identify IP and IQ in the sketch. So don't be too put off by this one. This is a physicsy question. Sorry, this is really a maths question that's been sort of disguised as a physics question. You don't actually really need to know any physics for this, you just need to know how to plot graphs. So the way I like to think of it is I always draw myself a little cos graph. So 2 pi, pi over 2, 1 minus 1. And then from just a basic cos x graph, I want to get to this. And sort of as I go along, just building up to this equation basically. And that's how I like to plot graphs. So first, this thing in front of the cos, IQ, that will basically just change the sort of minima and maxima from 1 and minus 1 to IQ and minus IQ. So you should know that through pretty basic graph transformations. Next, what does this IP thing do? That will shift the graph in the y direction by an amount IP. So it will transform the graph such that instead of being sort of centered around y equals 0, it will be centered around some value which will be IP. So it looks something like this, where now we've got minima and maxima that are basically IP minus IQ and IP plus IQ. Okay, so that's the sort of Y stuff sorted out. What about the X stuff? So we've got KL, which we're told in the question is 2 pi over lambda. And we want to sketch L. So our graph's basically going to be a plot of I against L. So what does that mean? Well, if sort of for one cycle of the graph, we have that 2 pi, so that's one whole cycle, one wavelength if you like, equals this 2 pi L over lambda. So L equals lambda. Okay, so what am I trying to say there? I'm trying to say that when we plot the graph of L against I, when we have our one cycle, that will be lambda. And that's what I've worked out here. So apologies, this is getting extremely messy. The question asks us for not 2 lambda. So because of what we've just talked about here, we know that we're going to need 2 full cycles of the cos graph. Okay, so now I'm just going to put together everything that I've just said here all onto one graph. So apologies, we're going to lose a bit of detail. Or a little bit of information because my screen's not big enough. So as I mentioned before, we'll have a graph centered around IP. And we'll have two cycles. So there's 1, 2. So this is L, this is I, this is 2 lambda, this is 1 lambda, and as we discussed before, this is IP plus IQ, and then this is IP minus IQ. We aren't really told the relative sizes of these, so it is possible that the graph would sort of cross this x-axis or the l-axis, but we don't know the relative sizes, so that's fine. So hopefully that makes sense. We've just put everything that I discussed up here together to make the graph. Okay. Next, we wish to use the interferometer to measure how the path length difference L changes with time by measuring the intensity at the detector as a function of time. The change in the path length difference is delta L. Indicate on your sketch the biggest delta L you can infer unambiguously from a measurement of intensity. So here we have the intensities, and you should be able to see that the biggest sort of change in intensity we can see, I'm going to mark this on the graph, so the biggest delta L will be when we have the biggest sort of change in intensity, if you like, that we can measure. So that would be going from somewhere like here to here. And so what's the delta L in this case? Well, we know that this is half of 1 full wavelength, so then it's lambda over 2.